In this video, we provide a complete overview of operations management and the task objects. In Automic Automation, operations management defines any function related to the handling of the day-to-day business of IT operations. Simply put, we manage the processes that execute in the environments. This includes supervision, recognizing and investigating abnormal behaviors, and taking action like escalation and remediation. At the core of operations management, we find the task objects. Task describes any executable object in a state of execution. The most common executable objects are jobs, file transfers, workflows, schedules, and events. The notion of execution is important. Certain objects are passive configuration objects like calendars. You can't execute them, and they don't need monitoring. Objects have properties, which designers and job owners configure using process assembly tools. By contrast, a task has defining characteristics. They are the task ID, the object type, start time, end time, activation state, current status, and a few more things. A jobs object currently executing is a different task than an aborted one. As such, they require different levels of attention on the part of operators. We'll explain the basic tenets of monitoring. That means supervising active tasks, recognizing abnormal situations, analyzing them, and taking the appropriate course of action as a result. The task is an instance of an executed object, and it is central to all operations management. We have executable objects. When executed, they perform some sort of workload. For this, a task is created, and the handling of this task falls on operations. Every single instance of an executed object is a task. The execution of a job 20 times creates 20 individual tasks, each with their own characteristics. We have different types of tasks for different types of objects. Some, like jobs and file transfers, are standalone. They perform a unit of work. Others, like workflows and schedules, are compounds. They integrate standalone objects to achieve certain goals, like sequencing and automation. Compound objects generate parent tasks, and the objects they contain are child tasks. Each task has defining characteristics like state of activation, current status, task ID, start time, end time, and so forth. The role of operations management is to oversee processes and guarantee continuity. When an object is executed, a task is activated. It's a live process. The standard life cycle of a task is activation, execution, completion, and deactivation when they are removed from active supervision. Automic Automation provides a dedicated interface called the Process Monitoring Perspective. It shows activated tasks with ID, start time, parent versus child, status, and more. When abnormal behaviors occur, like abends and unresolved dependencies, our job is to handle the situation. For this, we have actions. Each task type has its own list of actions. Let's briefly explain the most common methods for executing objects and activating tasks. There are more, such as code-based executions. The type of execution defines the type of task we're managing. First, we have the immediate single manual execution via the execute button. The task is activated immediately. Then we have the execute once function. We can change some of the settings, for example, set a future start time. We also have the cyclical or recurring execution, say every 20 minutes on business days only. Oftentimes you'll see a parent task, the C_period, associated with these executions. C-period objects set the cyclical parameters. We have restarts, ended and aborted tasks can be restarted by an operator. We have scheduled executions by ways of the schedule objects. This object can contain one or multiple executable objects with different properties and start times. An executed schedule object is a parent task with its own characteristics. Finally, we have rollbacks. In certain situations, a task can be rolled back to a certain point. Tasks have defining characteristics which impact the work of supervision. The same object executed twice activates two distinct tasks, each with its own set of characteristics. A task is defined by its object type. A job task is different from a workflow task. Each task has an ID number, date, a start and end time, and status, say active, aborted, or ended. These statuses are color-coded. Based on the specifics of a task, we have supervision elements. Each task generates various reports, like activation and execution. The execution report is a text file that contains the standard out and standard error of every process. We can access an object's execution, which is the full history of executions over time. Finally, we have monitors. These are tools which provide supervision capabilities in real time. The last monitor is always available from both the process assembly and process monitoring perspectives. Based on the task and its characteristics, we're able to perform a number of actions like restart, cancel, bypass dependencies, or something else. These actions vary based on the task. An aborted job task leads to one set of possible actions, a completed workflow to another set. Finally, there's one important aspect of task management, which is activation. A task is activated by executing the object and stays activated throughout its entire life cycle. Eventually, a task will likely take on an ended status, such as ended OK or aborted. If the situation is deemed normal, the task can be deactivated so it's no longer managed by operations. Deactivation is very important on many levels. Deactivating tasks means fewer items to manage, better database and system performance, records can be archived and purged, and much more. For this reason, process designers are told to deactivate their tasks automatically upon completion using certain object attributes. From the perspective of the operator, when a task is deactivated, it essentially no longer exists.